Hi, today we are going to see about that G81 cycle. That's a spot drilling cycle in OKUMA 3 plus 2 machine. So I'm telling that OKUMA, the type of machine that is MB56VA, and it's a variant of software. They are using OSP P300MA. So this is a software name. So actually I am telling that program only for this software only. Okay, so now we are going to see about the G81 cycle in Okuma machine. So same as like that, as usual Canada cycle format. This is a model program. So from N1 to N8, this is a tool details and holder details. So it is generated auto generated by the whatever the details you are given in the NX software. So this model program is fully generated in NX software actually. So after that, N9, that is as well as tool changing block. After that, NN1, if the tool number is same, then it will came into the NN1 line. So after that, G15, it's a work coordinate system selection, and H12 is a work offset number, and G30P4 is a reference return. So it is for Pokeyoke purpose. So many Pokeyokes are followed in so many softwares in Fanuco I series. They are using some Pokeyoke lines. So depending upon the programmer, the Pokeyoke line will be changed. So in so many softwares like a Fanuc and Siemens, they are using a G40, G80 and G15. So it is for Pokeyoke. If it in case the previous program doesn't have that cutter compensation radius or any other than that datum shift, if it is not switched off, then the same effect will replicate in the continued program. So then the actual program will be run in a very wrong way. So that's why they are using the Pokeyoke lines. So after that, G56 as well as tool length in positive direction, and G90 is absolute command. If you are using that G91, that is considered as an incremental method. So that's a relative method. Relative method. So after that, G11 X0 Y0 and Z0. So it's a datum shift line. So if we want to move the entire the program, for the current work offset, we want to move the positive direction in x axis, that will be 100 mm. So we can directly give that x 100. So if we want to move in y minus 100, so we can give directly. So we don't want to disturb the work offset, we can alter the single program. So remaining all the program as well as run as per the work coordinate system. So we can adjust in the each and individual programs. So the next line is a positioning line. What are the speed parameter we want to give? So speed parameter depends upon the material harness, and what are all the geometrical parameter of the tool. The depends upon these two categories. So if it in case if you are using that very hard material, and you are putting directly 100 drill, so it will affect that cutting. So you should consider the tool geometry as well as the uh, work harness and work materials. So this is the main thing. So after that, M03 is a clockwise. So most of the companies we are using the clockwise cutting tools. So after that, HE and DA, it's an tool offset number. So HA means tool height offset, and DA means what is the radius. So most of the cam generated program, most of the program doesn't use that cutter compensation is flexible. So they are predefined. So that's why they are giving that all the details in that block of N1 to N8. So the next one is G01 Z100, and feed rate 8500 M08. So feed rate 8500, it is very fast. So because we can save the time, so that's why they are giving a feed rate 8500 and coolant on. So Z100, it's an approach move, not an engage. It's an approach move at a safer distance, second level approach move. So after that, G71 M53. So G71 M53, it is the code for if you are putting more spots of drills. So that will be in a separate planes. Actually, that is non-linear planes. If it in case the plane having a 10 holes and another plane having a 10 height from the previous plane, so that will affect the tool movement, right? So that's why each and every hole, this will go to the tool will go to the Z50 level. So after that, this is a G81, this is a spot drilling cycle. So I will clearly explain the next slide. So G80, it's a Canada cycle cancel. So G10, datum shift cancel. Remaining all the things are primary and secondary uh, coolant on and spindle on. So these are the things getting off. After that, movement of the uh, tool spindle to the home reference return. So the next one is work setup. So now we are going to make the spot drill in like as they are given. So in X0 Y0 it's edge surface, side surface. So Z0 part top face. So if you are taking a one part X0 Y0 Z0, if the product quality, that means a precision, like if you are making a hole, that just having some dimensions, depth, diameters and roughness, and after that position from the datum surface. So many things, if it in case having some complexity, so you should have that take each and every part take offset. So that's it depends upon the work. So now we are going to make the hole, and operation details they are given. So drill hole diameter 3 mm and roughness, it is in a service hole, right? So we are going to make a spot drill. So this is a service purpose. So that's why there is no need of roughness, and drill depth also 1 mm it's enough. So pot thickness, it is a 20 mm thickness pot. So if the raw material is getting changed in the total thickness, then the Z0 point will be changed. So if it in case the pot thickness varies at 20 to 25 mm, then the pot will, then the tool will get broken. So we need to control this kind of problems in the raw material inward. So we need to add some face mill cycle. So after that we need to make holes. So as like that we need to do that. So this is a spot drilling cycle. So G81 is a spot drilling cycle, and G56 is a positive direction of the tool length. X50 and Y50, it's where we want to make the hole, that's an X value and Y value, and Z value is minus 1 mm. So we need to make a 1 mm depth of the spot drill. So that's why we are giving a Z minus 1.0. Then R3 value, retraction point value is a 3 mm. Then the feed rate is 50. It also depends upon the tool geometry and work material. Work material means what kind of material we are using, and its hardness. So this is all the thing. So then the HA is tool offset number. So in OKUMA having a 3 offsets, HA and HB and HC. So if you are using that different work offset, work tool height offset, we can mention it here. So M52 is written to I point. So we can make multiple holes with efficient protectivity. So that kind of thing we can use that M52. Otherwise, if you are making holes in the different planes, you should use that M53. So because it just we need to move up the tool at a certain level, that's a safer distance approach point of Z50. We are giving a Z50, so that's a M53 R point. So this is a tool path. So first of all, tool came up and position where we want to make the hole. So after that, it just came up into that approach level. 2 level is there. So one is first level approach, after that second level approach. First level approach 100 mm, after that 50 mm. Then after it just came up into that R point. R point is a 3 mm. So it came and stopped, and it just moved to the plunging cycle. So it's a directly single plunge. There is no more picking. So directly plunge into the minus 1.0. There is no shift amount. So in this drawing we are wrongly given. So there is no shift amount actually. So then after it just moved to the R point. So after that it is went out the home reference written. So this is a toolpath for the G81 cycle. So thank you so much for watching this video. Thank you.